to evaluate this integral using the Cauchy residue theorem. Now in this integrand, because we are having the sine function, so therefore we start with putting z equal to e the power iota theta and get sine theta in terms of z. And then we start the solution, right? Okay, let's move on to the solution. So here this is the given integral. We put z equal to e the power iota theta here, and from this we get dz to be e the power iota theta into iota d theta. And we know that sine theta is e the power iota theta minus e the power minus iota theta divided by 2 iota. So this will be changed into this e the power iota theta is our z. So this is z minus e the power minus iota theta becomes z the power minus 1, that is 1 by z, right? And it is multiplied with 1 divided by 2 iota. And now we are going to put all these details in this integral. And this integral will be equal to the integration. What is d theta? From here we get this further equal to, this is iota, e the power iota theta is z, and this is d theta, and this is dz. So what is d theta? It is dz divided by iota z. So writing here dz divided by iota z, and this is 5 minus 4. Okay, what is sine theta? We have 1 divided by 2 iota into z minus 1 by z. So this is 1 divided by 2 iota into z minus 1 by z. And because everything is in z now, so we have this integral over the circle, the unit circle mod z equal to 1. Because in this integral the limits are from 0 to 2 pi. So now for this we have the unit circle mod z equal to 1. So z moves in the anti-clockwise direction for this unit circle. Alright, next this is the circle C. So this is dz divided by iota z into 5 minus 2 divided by iota, and we get here z square minus 1 divided by z. Further we can solve this as, this is iota z into, this is 5 iota z minus 2z square plus 2 divided by iota z, which is cancelled out with each other. So we are having only this to be in the denominator, right? So we write here minus 2z square, I am writing this term first, plus 5 iota z plus 2. And now to find the poles for this integral, how to get the poles? Putting this denominator equal to 0 and get the point z to be equal to whatever you get, that will be your poles. So for this integral we take fz to be 1 divided by minus 2z square plus 5 iota z plus 2, and finding the poles now by taking this denominator equal to 0. So this is minus 2z square plus 5 iota z plus 2 equal to 0, or we get 2z square minus 5 iota z minus 2 equal to 0. So from here we get z to be equal to minus b plus minus square root of b square, that is 25 iota square, that is minus 25, minus 4 ac, so that becomes plus 4 into 2 and this 2, 16, divided by twice of this a, so this is 4, if the quadratic equation is az square plus bz plus c to be equal to 0. Alright, solving this further we get 5 iota plus minus, this becomes minus 9, so that is 3 iota divided by 4. So that further equal to, so this is 8 iota divided by 4 and 2 iota divided by 4. So this is 2 iota, and here we have iota divided by 2. So 2 iota and iota divided by 2. These are the two poles we have got. Out of these two poles, which of the pole lies inside this circle? The unit circle mod z equal to 1. 2 iota lies outside the circle. So iota by 2 lies inside the circle. What is iota by 2? The real part is 0 and the imaginary part is 1 by 2 if I write this in terms of these coordinates. So this is 0, 1 by 2, that is it is lying over here. So this point lies inside this circle. So now we are going to calculate the residue for this point. We always used to find the residue for the points lying inside the circle, right? So only pole within C is z equal to iota by 2, and the residue at the simple pole at z equal to iota by 2 is, the formula is limit z tending to iota by 2 on z minus iota by 2 f of z. So this is limit z tending to iota by 2, and this limit is on z minus iota by 2, and writing fz. What is fz? This. So 1 divided by minus 2z square plus 5 iota z plus 2. And we know that because iota by 2 is a root of this quadratic equation. So when we put z equal to iota by 2 in the numerator and denominator, we get the 0 by 0 form. So now we have to apply the L'Hopital's rule over here, and for that just derivate the numerator with respect to z, that is 1, and derivating the denominator with respect to z, we get minus 4z plus 5 iota, right? So when now you put the value z equal to iota by 2, we get 1 divided by minus 4 into iota by 2 plus 5 iota. So this 2 is cancelled out with this 4, and we get 5 iota minus 2 iota, that is, so this is 1 divided by 3 iota. And now we are going to apply the Cauchy's residue theorem to find the integral. So the integral is over the circle C dz divided by, so the integral is over the circle C dz divided by, we have to write that integral which is in terms of z, minus 2z square plus 5 iota z plus 2. So the value for this integral by Cauchy residue theorem is 2 pi iota is multiplied with the residue at the point which is lying inside the circle. So this is 2 pi iota. Okay, what is the residue? We have just calculated, it is 1 divided by 3 iota, right? So iota cancelled on, and we get 2 pi by 3. What is the original integral? It is d theta divided by 5 minus 4 sine of theta, and the limits are from 0 to 2 pi. This integral, we have changed this integral into the integral over the circle C, and this integral is in terms of z. We always have to change the integral in terms of z to get the solution, and this value is equal to 2 pi by 3. So this is how we solve such kind of questions. Okay, thank you. Stay blessed.